Welcome to this discussion. We are looking at solutions of simultaneous equations using matrix method, Form 3 mathematics. And the question we have reads, find the inverse of the matrix 2, 1, 3, 2, and hence solve the simultaneous equations below. That is 2x plus y is equal to 21 as our first equation, and also 3x plus 2y is equal to 34 as our second equation. So as part of the solution, we are supposed to find the inverse, but we cannot find the inverse without getting the determinant, and therefore the first thing in working out this question, one should always get the determinant. And how do we get the determinant? You take the product of the elements in the main diagonal, which is 2 times 2, then we minus the product of the elements in the minor diagonal, which is 3 times 1, and this one is going to give us 4 minus 3, giving us 1 as the determinant. Then the next thing we do is get the inverse, and the inverse is given by taking 1 over the determinant, which is 1. We multiply by, this time round we go and interchange the elements in the main diagonal, and since they are the same, we are going to maintain them as 2, 2. Then we change the signs of the elements in the minor diagonal, and therefore we are going to have negative 3 and negative 1 as our inverse. Having done that, we move down and write the two equations in matrix form. In equation 1, we have the coefficient of x is 2 and the coefficient of y is 1. Then in equation 2, the coefficient of x is 3 and the coefficient of y is 2. Then we have x, y separate, and this one is going to be equal to the constants, which is 21, 34. Having done that, now we go and take the inverse and multiply the inverse on both sides. That is, we are going to have 1 over 1 times the brackets. We will have simply 2, negative 3, then negative 1, 2. We multiply by the entire of this side, which is 2, 3, 1, 2. We have xy. Again, we go and take the inverse, which is 2, negative 1, negative 3, 2. Then we multiply it with the constants, which is 21, 34. We usually don't multiply the left hand side, because even if we do, we will get the identity matrix, and therefore the product of the two matrices or brackets will give us 1, 0, 0, 1 as our identity matrix. Then we multiply by xy, and this one will be equal to, this side now we have to multiply. We multiply row times column. 2 times 21 you get 42, plus negative 1 times 34 you get minus 34. Then negative 3 times 21 you get negative 63. We add 2 times 34, you get 68. We can now move down and drop the identity matrix such that we have our xy being equal to 42 plus minus 34 is the same as 42 minus 34, which is 8. And then negative 63, you add 68, you get positive 5. And therefore now we can go down and conclude that the value of x is going to be 8 and the value of y is going to be 5, and those are the solutions for the two simultaneous equations by matrix method. Thank you for watching and welcome to this channel. And in case you are watching this channel for the first time, kindly consider subscribing to the channel, comment, and also share to your friends.